Hello, my name is Henry Zhang. I'm an Application Engineer Manager for Power Product at Linear Technology. Today, I want to show you a small-size, very high-efficiency buck-boost converter. There are many applications that require a very wide input voltage range power supply. For these applications, the typical topology for this kind of step-up and step-down function are flyback or Sepic converters. Unfortunately, the flyback or Sepic converter are complicated. They require either a transformer or two inductors. Besides, the power component in these two converters has high voltage and current stresses. This requires large-size components and high power loss. As a result, for a typical 12-volt application, the overall converter efficiency is around 90%, which is not good enough. Another solution is a two-stage converter solution. For example, it can be a buck step-down stage followed by a boost step-up stage. As you can see, this two-stage converter is also complicated with a lot of components. Besides, the power has to go through two power conversion stages. This hurts efficiency. A smarter idea is to combine the buck and the boost into a single-stage, single-inductor converter. Here's how the single-stage buck-boost converter works. The simple concept is to operate this converter either in buck mode or boost mode, depending on whether the input voltage is higher or lower than the output voltage. For example, when the input voltage is lower than output voltage, which is 12 volt here, we always turn on the buck switch and regulate the output voltage with this boost switch. So the converter is in boost mode, like a boost converter. When the input voltage is higher than the output voltage, we always turn off this boost side switch and switch the output voltage with the buck switch. So the converter is operating in buck mode. Of course, such converter requires a smart controller that can decide whether the converter should be operated in boost mode or buck mode. The LTC3780 is such an intelligent controller. Depending on the operating conditions, the controller can operate the buck-boost converter smoothly in buck mode or boost mode. It's also a highly integrated controller with the current mode control circuitry and all the MOSFET gate driver in one control IC. In this topology, the passive dies has been replaced with synchronous MOSFET for very high efficiency. The current loop only requires one current sensing resistor for either buck mode or boost mode. With the LTC3780, the buck-boost converter can be 8 to 10% higher than the Sepic converter. For input range from 6 to 18 volt, and output is 12 volt and 5 amp power supply. The inductor size of the buck-boost converter can be 70% smaller than the inductor of the Sepic converter. The performance improvement with the buck-boost is obvious and very impressive. Furthermore, the solution can be even smaller. Here's the LTC3780 demo board. All these discrete components, except the power inductor, can be integrated in this tiny 15mm by 15mm by 3mm power module. The module can take up to 36 volt input and it can deliver 60 watts. It can have a 97% efficiency at 12 volt output. This is very cool. The module offers several advantages. It is a very simple, easy-to-use solution, can save design time. It is small with the highest power density. Several modules can be put in parallel with current sharing for high current or power applications. For example, this is a solution of a 4-piece of LTM4605 buck-boost module in parallel. It can be a 240 watt boost supply or 480 watt buck supply. Here are the thermal pictures of this board taken without airflow. Because of current mode control and good current sharing among modules, the temperature difference among modules is only 5 or 6 degrees. Because of very low thermal impedance of the module, the temperature rise of the board is only about 50 degrees. In summary, the 4-switch buck-boost converter offers the best solution for voltage step-up and step-down applications. For more information, please visit us at www.linear.com. Thank you for your time.